Process and variables. What is a process? A process is any operation/series which a particle object is accomplished. Within a process, we have an input or a feed, and that is a material that enters. And we also have an output or a product, and that's the material that exits. A process may consist of multiple steps, which is carried out in a process unit. Process units have associated a set of input and output called a process stream. So what we mean is we can have a stream going in to this condenser, and that would be considered as an input or a feed, and then we can have a stream coming out of this condenser, and that would be considered an output or a product. When we're talking about process units, a process may consist of multiple steps. What we mean is that we can have multiple streams in one process. So in order for us to carry out a process unit, we need to know the mass and volumes. We can calculate the mass or volume by using density, which is just mass over volume. And then we can also use the specific volume, which is just the inverse of the density, which is volume over mass. We can use density as a conversion factor. So if we're given density of carbon tetrachloride and the mass of 20 centimeters cubed, which is a volume because it's cubed, we can use the density equation, density equals mass over volume, plug that in to find your mass. So if we're given a mass, we can find a volume, and we just do so by converting the density equation into finding the volumetric equation. When we're using specific gravity, it is going to be density over the density reference value. The density reference value is going to be used for solids and liquids at water at 4 degrees C. Some values that we use are these. The density of a liquid or a solid in grams per centimeters cubed is equal to the specific gravity of that substance. So when we're talking about the specific gravity, for example, we can use 20 degrees C to the reference of our 4 degrees water. We can calculate that to be 0.6. Specific gravity and has no units when calculating. And we can multiply the specific gravity by the reference density to get the density of the substance. So if we're giving 2.0 of substance that's liquid, we can find the density by using the density reference from the table. Density of water at 4 degrees C equals 1,000 kilograms per meter cubed. The specific gravity, remember, is density over density reference. So then we just solve for density and we get specific gravity times the density reference, and then that we equal that to 2.0 times 10 to the third kilograms per meter cubed. With processes, we have flow rates, and if the process involves movement of a material from one point to another, we are given a flow rate, or we find a flow rate, and the rate at which the material is transported is the flow rate. There's two types of flow rates, a mass flow rate and a volumetric flow rate. A mass flow rate is mass over time, which we represent as m dot, and a volumetric flow rate is volume over time, which is what we represent as a v dot. We can relate the density to the flow rates, which would just be the density equals mass m dot over v dot. and we can manipulate the density equation as conversion factors to find the mass flow rates of volumetric flow rates of the process. With the flow rates, we can measure the flow rates using flow meters. And a flow meter is a device mounted in a process line that provides a continuous reading of the flow rate in the line. There's two most common flow rates that we use, and it's called a rotometer and a orifice meter. A rotometer is a vertical meter that has a stream going in from the bottom and a stream coming out from the top. When the stream pressures increase, when the stream increases to a maximum flow rate, there is a little marble that starts rising as the pressure of the flow rate increases. With the orifice meter, you have a stream coming in from the top, but then you have a pressure of that stream coming down into the orifice meter with a set mercury or fluid, and then giving the pressure coming out of that fluid pushing up into the next flow stream coming out.